Today we have the subject of reflection of light. It is useful for both for 10th and 9th classes. Now, coming to the definition of reflection, when a light falls on a mirror, it bounces back in another direction. This bouncing back of incident ray is called as reflection. For example, this is the incident ray, the light falling on the mirror, and it is the bouncing of the ray which is called as reflected ray. Now, coming to the laws of reflection. First law of reflection, the incident ray, the reflected ray and the normal all lie in the same plane, and this is the incident ray and this is the reflected ray and this is the normal means which is at 90 degrees to the mirror, and this is the normal, incident ray and reflected ray, all of them lie on vertical plane. Now coming to the second law of reflection, the angle of incidence is equal to angle of reflection. Angle of incidence means the angle between the normal and incident ray. For example, in this case, the angle between the incident ray and the normal is 35 degrees, and the angle between the normal and the reflected ray is also 35 degrees. Therefore, the second law of reflection is the angle of reflection is always equal to the angle of incidence. Coming to the spherical mirrors. You consider a hollow spherical glass. If you make a cut in it or a slice it like this, here we get a part of the spherical mirror, which is called as a spherical mirror. Here also we cut here, we get another part of a mirror. And now coming to the types of mirror, there is convex mirror and another is concave mirror. So convex mirror means which is bulging outside or curving outside is called as convex mirror, and inside it there is a non-reflecting surface, probably a silver coating. Here when the rays fall on it, they get reflected in another way. This is convex mirror. And in case of concave mirror, the curved inside portion or the bulging inward portion is called as concave mirror. Here it is non-reflecting surface. So for the convex mirror, outside portion is the reflecting surface. For concave mirror, inside portion is the reflecting surface. Coming to the different types of light rays, here there is a parallel beam of light where the light rays are parallel to each other. They are not intersecting. And convergent rays, when the rays from the source fall at a particular point, or when the rays from the source converge at a particular point, they are called as convergent rays. Divergent rays, when the rays from a source deviate from the source or from the point and they never meet, they are called as divergent rays. Now coming to the nomenclature of the spherical mirrors, we have here, this is the mirror. Here we have concave mirror and convex mirror. Again, concave mirror is curved inside. This is the reflecting surface, and here this is the non-reflecting surface. Here first of all we have a center of curvature. This is called as C as the center of curvature. It means here we take C as center, and if we can draw a curve like this. Therefore, this is curvature and this is called as center of curvature. It is nothing but radius of sphere, but we take in the sphere, we take only part of the sphere, part of the hollow sphere as the concave mirror. And this is called as center of the curvature, and this is the pole. The mid portion of the mirror is called as pole. The midpoint of the mirror is called as the pole. And focus is the point at which all the rays will be converged or concentrated. For example, we can say some rays, there are some rays, example sun rays, they fall, suppose this is one ray, then that is converged here, another ray again that is focused here, and we get another parallel ray that is concentrating here, and say there is another parallel ray, this is also concentrating here. So when all the rays here, example is some parallel rays are incidenting and again reflecting, reflecting, they are concentrated or focused at a particular point. That point at which reflected rays are focused or concentrated is called as focus. Now the distance between the pole and focus is called as focal length. The distance between the pole and focus, here PF is called as focal length. And coming to another point, principal axis. Principal axis is the line joining of center of curvature and the pole. If you join the center of curvature and pole and extend it, it is called as principal axis. And all the points, that is center of curvature, focus and pole, they lie on the principal axis. And this is for convex mirror. So here we have got this is the reflecting, this is the that is the surface, coating surface, and this is the reflecting surface. Here the rays like this, suppose these are the rays, they try to reflect like this. Here there is another ray, it gets reflected, and there is another ray, it gets reflected here. So these are the lines of reflection, and this is also the line of reflection, and there is another ray, it is getting reflected like this. Now if they appear, if you extend these lines, all these lines will appear to focus at a particular point. Just like concave mirror, there is reflection is inside the surface and they are exactly meeting at the focus point. In case of convex mirror, the lines are appear to focus on the focus point. So this is the center of curvature, and this is the pole, and this is the principal axis. Remember that this is the hollow sphere of glass. Here also hollow sphere of glass. Only this portion is called as mirror portion. This is concave mirror and this is convex mirror. So here we can say that the focus for concave mirror is what is real. It is real. It is at point P, and here the focus is appearing above or beyond the surface. It is called as virtual focus. It is called as virtual focus. That is dotted lines. We are extending the dotted lines to get the virtual focus. And here there is another a point called as aperture. Aperture indicates the size of the mirror. Size of the mirror. For example, here this is from the spherical surface. If you slice it or cut it, now this portion is called as aperture, and we can say that the reflecting surface, the part of a sphere which is used for reflecting of rays, is called as aperture. Here we can say this portion is called as aperture, and this is called as size of the aperture. This is called as the size of the aperture. So aperture indicates the size of the mirror and the reflecting surface of the mirror. So this is about the nomenclature of the mirrors. So in the next class we study about virtual images, real images, and different locations of objects and images. Thank you.